So I'm going to talk about vector notation using unit direction vectors, namely the x hat and y hat vectors. First, they're called unit direction vectors because they have a magnitude of 1, but they have direction, right? Okay, so let's just dive in. Say, using these unit vectors in vector addition. v3 is equal to v1 plus v2. Alright, v1 can be expressed as 3x hat plus 2y hat plus 2x hat plus 3y hat. Alright, so collecting like terms, we get 5x hat plus 5y hat. And so this is now v3. And the magnitude of v3 is equal to square root of 5 squared plus 5 squared, which is just 5 radical 2. Okay, in vector subtraction, we are, say I want to get v2 minus v1. Alright, what is that exactly? What does that look like? v2 minus v1. Just copy this, paste it. Okay. So v2 minus v1 is actually this vector. This is v2 minus v1. So using those unit vectors, we can say 2x hat plus 3y hat minus 3x hat plus 2y hat. And then collecting like terms, we get minus 1 x hat plus 1 y hat. And that has a magnitude, so v2 minus v1 magnitude. The magnitude of this vector is equal to square root of 2. And this vector is actually this. You can paste it right there. It's actually that one. Oops, colors. And it's kinda like 1, 1, but my axes are a little off. Anyway, so these vectors, these unit vectors aren't in this orientation, the xy direction, but you know it's not a special direction. You can have another direction that's labeled E1 and E2. These two directions are perpendicular to each other, such that you get these unit vectors that are 30 degrees. Let's say just for this example, they're 30 degrees off of each other. So we have to investigate how this is how this vector 1 is being represented in the xy oops xy space. v1 is equal to 3x hat plus 4y hat. But just as I said, x and y is not exactly a special direction. This direction can also have a v1, which has some number e1 hat plus some number e2 hat, right? So what are those numbers? Well, we can go find out by trying to figure out the relationship between x hat and y hat, and then because x hat can be represented as a linear combination of e1 and e2, and actually I'll just show you. It's it's easier said than it's easier understood when it's shown. So this is theta, just 30 degrees, right? So we got um, we got y hat. First, we're going to investigate y hat. So this one right here is equal to E2 cosine theta, right? This part of E2 is in the y hat direction, right? And you add this guy, E1 hat sine theta. This part of E1 is in the y hat direction. So this is their relationship. When I said linear combination, this is what I mean. It's like combination of E1 and E2 can add up to y hat. So x hat here, going back like that, equals E2 sine theta. Oh, minus, going that direction, right? And this one is plus E1 hat. Oh, forgot the hat. Cosine theta. And as you can see, the x hat is a linear combination of E1 and E2. Why did I want to do that? Because I can do this. Oops. Copy that. Paste it here. Okay. Go over here and just plug those in. 3 minus E2 hat sine theta plus E1 hat cosine theta. And what's the next one? Plus 4. Then just plug in the y. E2 hat cosine theta plus E1 hat sine theta. Okay. And we're almost done. We got V1 now expressed in the E1, E2 plane, which is 3 cosine theta plus 4 sine theta plus the E2 direction, right? 4 cosine theta minus 3 sine theta. Okay, so now this is the E1, so 3 cosine 30 degrees, right? Plus 4 sine 30 degrees. And that one comes out to be, plug it into the calculator, comes out to be 4.5981. This one right here is 4 cosine theta minus 3 sine theta. Oh, this is 30 degrees. 30 degrees. And that's going to be equal to 1.96. So V1 expressed in this space is going to be E1 hat 4.5981 plus 1.9641E2 hat. Okay, so this is V1 here, and this is V1 in the E2 E1 space, and this is V1 the E and in the XY space. But notice V1's magnitude here is 5, and V1's magnitude here is 5. Magnitudes did not change, it's just the direction of the vector changed based on the space you're in. So no one space is special, I guess. So, and these are static frames, but there are frames that actually rotate. All right. So we got, see this frame right here, t0. It's gonna rotate at t1. It's gonna rotate t2. And when do these frames actually become relevant? relevant? Well, if you have like a force that is actually resting in that frame, like centripetal force, right? Force. Actually, centripetal force is going in, but some other force that's uh, resting in this frame, right? So I can say that force is equal to 1, 2, 3, 4 e2 hat plus 0 e1 hat at all times. So I can use this frame so that my force is not changing with time, you know, because this frame is already rotating. So I think that's all for this one. Hope it helps.